3.2 Evaporation. Water evaporates at room temperature. In fact, evaporation may take place at lower temperature, even when it is close to freezing point. And from our experience, we know that evaporation is faster at a higher temperature. 1. Evaporation and boiling. Evaporation is the vaporization of water takes place at any temperature, while boiling takes place at boiling point only. Evaporation occurs when more energetic molecules on the liquid surface escape from the liquid. These molecules absorb energy from its surrounding molecules. As the more energetic molecules leave to become vapor, the liquid molecules have a lower average kinetic energy, and hence evaporation always produces a cooling effect. 2. Cooling effect of evaporation. If you wet your hand using alcohol pad, or when sweat evaporates on our skin, we feel cold. When alcohol or sweat evaporates, they absorb latent heat from our skin, and so we feel cold. When humidity is high, sweat stays on our skin longer. We feel uncomfortable and hot as the sweat cannot evaporate quickly. 3. Evaporation and molecular motion. A. Explaining the cooling effect. Evaporation takes place on the liquid surface only. Why? Liquid molecules collide with each other frequently, exchanging their energies. Some molecules gain enough energy to escape from the liquid surface and become vapor. Those molecules below the liquid surface can hardly have enough energy to overcome all the attractions by its laboring molecules. On the other hand, vapor molecules also collide. Some lose energy in the collisions, and some return back to the liquid body. The net rate of evaporation is the difference between the rate of escape and rate of return. B. Factors affecting evaporation. Experiment 3A. Factors affecting evaporation.
Firstly, wet a cloth. Then measure the mass of this wet cloth. Record the mass. Unfold the wet cloth. Use a hairdryer to blow hot wind to the cloth. After 5 minutes, measure the mass of the cloth again. Find the difference in the mass. Now, repeat the above steps under different conditions. Ensure that the cloth contains roughly the same amount of water every time. In condition 1, use the hairdryer to blow cool wind to the cloth. In condition 2, leave the wet cloth in a windless environment. In condition 3, fold the wet cloth and place it in a windless environment. How does the mass of the cloth change after 5 minutes under each condition?
Obviously, evaporation takes place faster in a windy environment, and so producing a greater cooling effect. By the way, don't forget to use cool wind in the experiment. Other than temperature and wind condition, We also know that the evaporation is faster if the surface area increases. Students in the basketball court often sweep out the puddles to improve their evaporation. Table 3.2b summarizes the factors affecting evaporation, which includes temperature, surface area, and density of vapor. Example 8. Cooling effect of sweating. Sweating is important to regulate body temperature. 1 kilogram of sweat can lower the body temperature by about 11 degrees Celsius. Without sweating, or if the humidity is high, a sportsman can easily get a heat stroke when his body temperature rises too much. By the way, sweat evaporates without increasing temperature. The sweat needs not be heated up to boiling point. So the energy change of sweat to evaporate is only the latent heat of vaporization. Q equals ml. Do check point 5 on the next page.